One. All right, we're now recording. Excellent. So welcome everyone to what I call webinar number 13. It's a continuation from year one of the campaign, but this is essentially webinar number 13. And I affectionately called this year two of the campaign begins, discussion on data counts, year one data champions, ICESat-2 data, and what lies ahead. So I figured it would be great to discuss, sorry, 1 second here. I just, my computer just went bonkers. Hold on. I'll be right back in a second. All right. Can everybody hear me? Dorian and Kristen, let me know, please.
Yep, you're good.
All right. Sorry about that, but all of a sudden, my screen went completely blank, and I had to relog back in with my my card. So sorry about that. So once again, that's technology for you. So so today, what we're going to talk about. We're going to talk about the campaign and what happened during year one, and then, you know, somewhat lies ahead. But really excited to announce that we have a great campaign team. We have a bigger campaign team this year, which is awesome. Once again, I am Brian Campbell. I'm at the NASA Wallops Flight Facility in Virginia in the United States, and I lead the campaign. I'm also the tree science lead for the NASA Globe Observer Citizen Science Tool, and I work on the ICESat-2 satellite mission, and I'm on the social media team for the NASA Globe Observer. We hope to have a great year planned for the campaign. We hope to get a lot of student research projects that are affiliated with the campaign. And we'll talk a little bit more about that later. But I want the campaign team members that are here, I want them to be able to introduce themselves and say hello to everyone, so you get at least a voice with a name, potentially, you know these people. Peter Nelson is the co-lead for the campaign. He's from Oregon State University in Oregon, USA. He can't be with us today. He is at another meeting. He's at a week-long meeting. But he is the land cover science lead for the NASA Globe Observer. So he brings a lot to the table with land cover and using online tools, which is his expertise, using online tools to look at data in many different ways. So, and to help students, work on the research projects and make sense of the data that they collect and that others have collected, including those coming from NASA satellites and airborne missions. And then I want to introduce, a lot of you know her already, Dorian Janney. She's at the NASA Goddard Space Flight Center in Maryland, USA. And Dorian, if you want to say hello and introduce yourself a little more.
Sure, I'm happy to. Hi, I'm Dorian Janney, and I'm probably most closely affiliated when it comes to the GLOBE program with being all abuzz with mosquitoes. So I am the education lead for the GLOBE Mission mosquito campaign. I also am the outreach coordinator for the Global Precipitation Measurement Mission, which is a mission that measures precipitation around the world. And if anybody should kind of have more questions or want any more information on how and why we measure precipitation from space, I'm a person to ask about that. And let's see, I was a teacher for 30 years. I started off at the early childhood level, and then by the time I was done, I actually had moved my way up through early childhood, elementary, middle school, high school, and all along I also worked with adults. So I've been over at Goddard Space Flight Center since 2011, and really, really love it. So there's that's what I'm up to.
Excellent, thank you, Dorian. And next we have Christopher Schumann. He is at the NASA Goddard Space Flight Center with UMBC, and also in Maryland, USA, at the same center that Dorian is. And Christopher, I saw that you're on. Are you back? And if you want to introduce yourself a little more.
Okay, just getting used to Zoom. Can you hear me now?
Yep, we're good.
Okay. So I'm a cryospheric scientist. I've been working in the field since 1992 and have been part of the original ICESat mission, and will be trying to contribute by getting to know the ICESat-2 data set as version 2 becomes available sometime this month. So not many trees in Antarctica and Greenland, but I will try to look at the rest of the globe with the ICESat-2 mission.
Excellent, thank you, and thank you so much for being a part of our team.
Thanks for having me.
And we have Peter Falcon. I don't know if he got to call in yet. He's also, he's at a meeting. Yeah.
Yeah.
All right,
so,
awesome.
Actually at lunch with a few other people right now, so we hear the noise. I apologize. So yeah, I'm Peter Falcon. I work at Mission, a globe campaign for the social media portion, and I worked with Brian and Dorian in the past on the INSU campaign as well. So I'm happy to be on the tree one now.
Awesome. Thank you, Peter. So yeah, as you see, we have a great team that is that brings so many different things to the table. And one of the major things that we want to focus on is all of us have worked with students in the past, present, and will in the future. So we all want to be able to have students to be able to take this data, whether they're looking at tree height data or land cover data or greenings, and then be able to take their data and data that others have submitted to the Globe database via the student part of the website, as well as the NASA Globe Observer Citizen Science tool. We want the students to be able to use all the data, as much data as they want, to be able to design some research projects. And we have some ways that we're thinking about, we want to ease that burden on the students for, coming up with, just spontaneous research questions. So we have some guiding investigative questions we're going to talk about, and those from ENSO, you might remember those as well, and from year one of the campaign. All right, so a little bit about the, this is kind of the program, the campaign in a nutshell. We're talking about trees, so we talk about why trees, why are trees important. We've talked in the past year to tree research experts from the National Park Service, from the scientific research, from academia, and from students who have become experts in taking observations and measurements of trees and land cover, things like that in their environment. Also, we have, at NASA, we have lots of satellite data. We have lots of maps, we have lots of visuals, lots of visualization tools. So we have lots of ways to look at that data, and lots of data for students to use in the research projects. We have once again, we have the student data. We have the globe measurements, and one thing that's pretty cool is that, in order to get the biggest picture, the most complete picture of what's happening in your environment and why trees matter and why land cover matters, is from the measurements, but also we like to bring in personal aspects like cultural. You might remember last year's webinar with Oscar Garza and the Salish tribe, where he talked about not just the science behind the tree height measurements, but what trees meant culturally to their Native American culture. So we want to bring all that into it, because we don't want to just do science for the sake of just doing science. We want science and what it means, and it means different things to many different people, different cultures, and different groups. So yeah, so that's what we want to do. We want to try to make it as personal as possible, so there's an interest in this. Because you think of trees, you look at trees, everybody has a story about a tree. They've had their favorite tree. They see trees, just about every day. But as Christopher mentioned, if you're hanging around Greenland and Antarctica, often, you know, you're not going to see those trees. You're going to miss those. But yeah, so trees play a big part in our everyday life. Global student and school collaboration networking. So we want schools to work together. The data's out there. The schools are out there willing. So I think the hardest part is to get those schools together. And, you know, we hope to have a webinar or two this year where we bring schools together just to talk about stuff, kind of like an open forum for exploration and a collaboration. So we want to bring these schools together to do measurements. As part of the ENSO campaign that we had several years ago, where Dorian and Peter Falcon were part of it, we had a bunch of schools that were interacting, everywhere from schools interacting the United States and Africa, you know, Croatia and Italy, and, you know, lots of schools all over the planet were interacting with each other and looking at the measurements that each were taking, and then developing research projects. Some were research projects just by individual schools, some were collaborative research projects from different countries. And then I have here in bold outline is our student research projects. And in the US, it's a student research symposia, and then the International Virtual Student Symposia, which is the online, basically online science fair, which get judged by professional judges like other educators, researchers, scientists, you know, Globe personnel. So they all get, judged by high qualified individuals. So I have a bold because we really want to focus this part of the campaign, this year of the campaign, on getting student research projects out there. You know, how to make trees, you know, how we can make research projects out of, you know, from tree research, from land cover research, from greenings, and there's lots of data out there to use that. And then put all that together, we got the Trees campaign. So let's look quickly at some of the year one metrics and data counts. So this runs from September 15, 2018, when the campaign began, all the way through September 14th of 2019. So that is 1 year. And in that 1 year, we have 8,270 tree height measurements from 4,461 sites. So that's pretty awesome stuff right there. I just want to let you know that when the tree height measurement began with Globe back in 1995, from 1995, around April 23rd, 1995, all the way through the day before the campaign began, so April 23rd, 1995 through September 14th, 2018, there were just over 11,000 tree height measurements. And that's in like 23 years, 11,000 measurements. Since the campaign began, we've had 8,270. We actually have more now. This is just 1 year of the campaign, 8,270 tree height measurements. Now, these measurements come in from the students, from the teachers, and from the NASA Globe Observer. But that's a lot of awesome data to use from all over the planet. We have 7,239 land cover measurements from 5,334 sites, and 6,660 greenings, green up, green down measurements from 353 sites. The majority of these are from the European Phenology campaign, which is an amazing campaign that, you know, I love for our campaign to work with. And I've started some initial discussions with some of the folks at the European Phenology campaign, and, you know, they're all for it. So, you know, stay tuned for that. What you see in these images down here on the left side, these are where all those dots is where a tree observation came from during year one of the campaign. In the middle are the countries that have basically, these are the individual countries that correspond to those tree height measurements you see on the left. And then on the right, these are all the tree height photos that come in. Now, these photos came in from the NASA Globe Observer, because as you know, when you do just the regular database entry, you can't submit a photo like you can on the NASA Globe Observer. And then we had 12 webinars. We had 11 campaign specific, and we had one special. And that special was it was a NASA live video from the Goddard Space Flight Center television studio. And that was about the campaign and the ICESat-2 mission and some hands-on activities. For the webinars, we had 655 direct participants, and now those are not including students directly, because we had some student counts. We had some classrooms in there, and I'm sorry to put this in here, but we had over 500 students who were part of the webinars, and these participants came from 40 countries. We have 38 blogs with over 22,000 views and 58 uploaded documents. So all this comes from year one. And this is thanks to all of you for taking such amazing measurements and getting the understanding that tree height measurements and land cover and greening measurements are just so important. And you've contributed to the database that students and citizen scientists can go to if they want to, but especially students can go to really beef up the data analysis, for their student research projects. Here are the participating countries for year one. You can see all the green colored ones are the very active participating countries who participated in the webinars and did data collection of tree height or land cover or greenings, or all the above. Some did all the above. So you can see Europe is pretty thick right there in green. So great job. The United States, lots of South America. Africa is pretty good. We have to get some more there for Africa. But as you can see, some of the countries like Nigeria, South Africa, Benin, Egypt, so you have all those in there. In the Middle East, we have several as well, Asia, and then Australia. So yeah, we have some, and Indonesia. So we have some, a great participation for this. We would like to have more, because the more participation we have, the more data we have for the students to evaluate and analyze and be able to use in the research projects. And you're going to hear me mentioning the term student research projects a lot. Since this is the Trees Around the Globe student research campaign, that's what we're striving for. We want students to really get that information. And as I mentioned, we're going to have a couple webinars this year where it's just an open forum of educators, hopefully with students coming in and talking to each other and finding out what you can do with collaboration, and any questions about the data that's coming in. I want to also share this. I created a little graph from the tree data that came in from the 8,270 tree height data observations coming in. Once again, this time period was beginning of the campaign, September 15, 2018 through September 14th of 2019. The average tree height out of all these measurements was approximately 10.34 meters or 33.92 feet. So yeah, so that's kind of that's the average out of all these trees, and that's global measurement. The largest tree observed, and I put this out there because I want people to see if they can beat this, but this is the largest tree observed was 96.89 meters or 317.88 feet tall, which is just an unbelievable over 30 stories tall tree. This happens to be a redwood in Oric, California, called Big Tree Wayside, and it's approximately 1,500 years old, and over approximately, according to this, 317.88 feet. I went in and I looked at the record in the database, and there isn't any specific number for the height. It just says everywhere you look for it on Google, it says it's over 300 foot tall. So we have a good measurement coming in. And if you want to take a look at it, there's pictures of it. There's the latitude and longitude for that location where the measurement was taken. So I just wanted, thank the folks for taking these measurements. This happened to be a NASA Globe Observer measurement of someone. So this is really cool to see, but let's see if you can go out and beat this large tree observed. It's a really big one, so it's going to be a really tough thing to do. But we like to show this type of thing because measuring a tall tree is hard, because you really have to walk far back from the tree. This person had to have walked back hundreds and hundreds and hundreds of feet from the tree in order to use the clinometer either on the phone, and you can, the paper one, or a plastic handheld clinometer, but you really have to be precise and really accurate when it comes to trying to take these measurements, because the taller the tree, that angle gets a little tricky to measure using the clinometer or even using your phone, the NASA Globe Observer app on your phone. So yeah, it's a really tricky thing sometimes. All right. So I'm going to pause here for any questions. Anybody have any questions? I don't see any in the chat right now, but if anybody has any questions, you can unmute yourself and ask a question. That would be, it's a good time to do it. Or if any of my campaign colleagues have any things to say, Dorian or Christopher or Peter.
Brian, as always, you're doing a great job. You know, I love looking at the data. I love seeing the progress that's being made, seeing all of the measurements that are coming in. And I'm looking forward to seeing more. I wish, as I was listening to you talk about the tallest tree, I was out looking at some in Yosemite, and I saw these beautiful huge sequoias. And man, I kicked myself for not trying to have gotten a measurement when I was out there.
Yeah, I know a couple people were also talking about that when they were out in, out in the Sequoia National Park and where the redwoods are as well, that they didn't get these tree height measurements. And one person was out, I can't remember who it was exactly who I was talking to in passing, but they tried to do it, but there were just too many people in the way and they couldn't get the measurement done, and they couldn't get a clear view of the actual top of the tree that they were trying to measure. So they scrapped it, which is a shame. But, I would have liked to just seen what they could have gotten. That would have been really cool.
Hey, Brian.
Hello.
It's Christopher.
Hey, Christopher.
Are we keeping track of field experiences like that, where people, the trees are too dense together, the ground is too uneven? Dorian's mentioning Yosemite made me think of that. That's some rugged terrain in that general area.
Yeah, we hope to. And I know a lot when they put their information, they have a section, especially in both the student data sheet and the NASA Globe Observer. There's a box for metadata. So we have had some put some in that metadata in those metadata boxes, but a lot of it becomes I guess anecdotal at some point. So we have to try to find the happy medium between the two.
Hello, Brian.
Hello, Umar. How are you?
Me?
Yes.
Yes, I wanted to ask that I'm new to the Globe program, and would you guide me throughout this?
Yeah, sure. Yep.
Thank you. It's okay.
All right. Yeah, well, thank you for joining us. That's great, and welcome to the Globe program. And Umar, my email will be at the end of the webinar today, so you can send me an email if you like, and we can go from there. I can bring you through all about the campaign, a little more than what we're going to talk about today, to get you up to speed on everything. So how does that sound?
Yes, sir. Yes, sir. Thank you. I'm from Pakistan.
Great. Well, welcome.
Thank you. And I'm only 12-year-old, and you would be so surprised to hear that.
That's great.
Thank you.
Excellent. Sure. All right. Anything else from anybody? All right. So let's go on here. What we also have, part of the campaign called intensive observation periods. These are something that Globe has done for a while. We kind of brought them back last year. And what they are is focused periods of time where students are encouraged to collect large amounts of tree height and land cover data and enter in a Globe database. So what we're striving for are lots of measurements in a short amount of time, what's also called data density. And also, if you're taking tree height measurements, one thing we like to recommend is that if you have an area where there's, like a grove of trees, there's a lot of trees in a smaller area, get as many of those tree height measurements as you can. That helps, also for data density as well. Data that's collected during an IOP really provides a great, a much more robust data set for students, scientists, researchers, and educators to use. So, you know, that's great. And what we have is, you know, kind of as a small reward for this, we have these digital badges that you see at the bottom here. And on the left side, you see the two badges. These are for tree height for the participant and for the winner. And then on the right, you see for the land cover participant and winner. I just wanted to shout out a couple names here. January of 2019 was our first. It was our first intensive observation period for year one, and that was for tree height. And the winner was Marina Sambolik and her students from Croatia. And in April 2019, we did land cover, and we had, I should mention, January we had 691 tree height measurements. April 2019, we had 3,520 land cover measurements, and the winner for that was Jeff Bauman and his students from Michigan at Shoemate Middle School. July 2019, we went back to tree height. We had 717 measurements, and the winner was Yusin Lee and students from the Taiwan Partnership. And right now, we are currently having an IOP, an intensive observation period, for the land cover measurement. And right now, the current leader is James Less and his students from Cape Coral, Florida in the United States. So, you know, let's keep those coming in. We have lots of land cover measurements coming in. That's awesome stuff. But we just wanted, this is kind of showing you our little appreciation here that if you even take one measurement of tree height or land cover during this, we will give you during one of the observation periods, you will get one of the badges, but the one that only one person will get during each IOP is the winner badge. And that gets sent, you can have it sent to you, as well as it will be put on your Globe account. Everybody who participated in all of these from January, April, July, all of the badges, digital badges are on their accounts, are on their personal pages on the Globe website. So people really like to collect these because there's lots of them that come out for different things. So you know, stay tuned and go out there along with taking tree height measurements. Take land cover measurements as part of the IOP. What I also want to strive is that tree height measurements and land cover measurements go hand in hand. When you're looking at this, you know, this space, this, you know, 50 meter, you know, by 50 meter space where you're taking land cover measurements. A lot of times there's trees in that basically that pixel, that location you're looking at, that you're standing in. So why not, when you're in there doing land cover measurements, if there's any trees in that area, take trees at that same location, take tree height measurements right there when you're taking the land cover measurements. It's so easy, especially if you use the app. If you understand how to use the app, you know, it only takes about 30 seconds to a minute to do a tree height observation. It's super fast. So, and it's really fun to do. So, you know, take those measurements because, you know, the more measurements, the better, because that just gives the students more of a database to work from. All right. As I mentioned, right now we're having the land cover intensive observation period, and that will last until October 31st of this year. And then the next one will be in January again, and that will be tree height. Since we're talking about student research project, I just wanted to share one of those that was submitted last year. And this was from the Shoemate Middle School from Lillian, Thomas, and Brady with their teacher, Mr. Jeff Bauman. And what's cool about this research project, actually there's something very cool about it and something kind of sad about it, you know, in my opinion. And it's an awesome poster, okay? It's an awesome project. They went out and the students went out and took lots of tree height measurements around their school. And then what they were going to do is they were going to compare them to the ICESat-2 tree height data, you know, when it came, you know, if it came over their school during the times that they took the observations. The tough part about this is that they had to submit their IVSS student research project before the ICESat-2 data actually was publicly released. It was supposed to be released earlier, but it got pushed off for a little bit for different reasons. So it had to be pushed off a little bit. So they had to submit their information. But what they did in their poster, which was great, is they went back and they looked at the data, and then they said in here, as part of their abstract and research question and discussion, they talked about how important how important it is that they needed that ICESat-2 data. And they talked about the data they collected, and they can't wait until they can, actually compare the data to the ICESat-2 data, and why it's really vital to have these two levels of observations: the ground-based tree height data and the satellite-based tree height data. So it was really great how they went from, expecting to do one thing, realized they couldn't do it because the data wasn't out yet, but then turned it around into a research project about why the data is important and why it needs to be released and why it needs to be out there. So very cool project. And I saw this poster in person at the Globe annual meeting in July, which is really cool. And I got to talk to some of the students and of course, Mr. Bauman about it. So hopefully we have lots of people who are going to take tree height measurements and do some ICESat-2, comparisons if and when the satellite flies over your location, which can be a tricky thing as well. And we'll learn a little bit about that during next month's webinar. So, since we're talking about student research, what we really want to do here is to help students along the way when they're trying to come up with research questions related to the campaign, related to trees or land cover, things like that. So we have these guiding investigative questions that are meant for students to, to explore these questions while they're taking the research, while they're trying to make sense of the data. And I'm not going to read through all these here, but I'll pull a couple out. Some things to think about when they're taking measurements. What can measuring tree height tell us about our local ecosystem? Are the trees in my area native or invasive? What are the barriers for comparing globe tree height data to the ICESat-2 tree height data? Okay. And, how much water do the trees in my area require per month? I believe that's a great question that came from Dorian, because she works with the Global Precipitation Measurement Mission. So they're looking at global precipitation and, the precipitation basically, what waters those trees. And one other one I wanted to mention is where are trees growing and why are they there? It's a super big question, but it's really cool to try to think about, why are trees, you walk outside, why are there trees there? Were they planted by someone? Are they very old and we don't know when they were planted? Did a spore come from another tree and, it's seeded and then it grew from there? Lots of cool questions. I don't know how to answer all those questions, in a lot of places, but it's a great one of the guiding investigative questions to help students explore, the data that they're collecting. So I'm going to pause here again to see if anybody has any questions about these. And these are all up on our website as well, on the Globe website, these guiding investigative questions for you to take a look at and to show your students. And if you have any more that you think should be up there, let me know. If there's other questions that you'd really like to have up there. We'll be talking about more about these when we have our, our open forum webinar, in the next couple months. A little more specifically about, how can students look at and explore these questions. Anybody have any comments or questions?
Would you guide me how to measure the height, and also that why are you showing us these questions?
So these questions are meant to, when you do the tree height measurements, and you can see it on the website. I'll go through the website. Then when you go through the website, it shows you what you need to do to go measure tree height and how to do it. So, and then these questions are set up so that as you're taking tree height measurements and you're getting that data and you're looking around your environment and possibly doing land cover as well, to think of these questions, while you're measuring the trees, while you're taking the data, and it can help you, determine, or help you craft, some questions, some of your own questions, you know, for potential student research projects.
You mean that this is the reason why we are taking the globe program and the tree height and the land cover measurements?
Yeah, these are some of the yeah, that's great. That's exactly. So yeah, so we're trying to answer questions about our local environment by taking these tree height measurements. You know, why we're taking these tree height measurements is a great question. You know, that could be a research question. Why am I taking tree height measurements? But these questions will help you understand why you're taking these measurements. I'm not going to give any answers to these questions because these questions are meant for students such as yourself to explore or to think about while you're taking the observation.
Okay, thank you. Now I have understood.
Okay. And as I mentioned, coming soon, we hope to collaborate with the European Phenology campaign because they are doing some great observations, lots of observations, looking at green up and green down, looking at, you know, the bud burst in the beginning of the flowering season and when trees start growing, and then when trees start losing their leaves and their buds and everything, you know, so the green up, green down. And I know Marcus is on right now from Switzerland, and he's an expert in the greenings, and he gave a great webinar that you can see in the archived webinars during last year's campaign. So, you know, we're going to be hopefully discussing more about the European Phenology campaign in the near future, so stay tuned for that. All right, so now what I'm going to do is I'm going to stop sharing here, and I'm going to reshare. I'm going to go to, I'm going to go to the website just to walk through it a little bit. All right, here we go. Here's the website. And actually, let me go to, that's too long a URL, but I guess Globe might not let me do it. Oh yeah, there's the URL up above. It's still kind of long, globe.gov/web/trees. Okay, you got that. You can see that whole thing up top there, hopefully. So here's the website, and I'm going to show you just a couple of the sections here because I just wanted to bring people back you know, on base with everything that's happening with the website. So here's the landing page that you get, and it talks about the campaign and what it is. There's an intro video here that I'll show you a little later on, and then it talks about you know, when the campaign started, related measurement programs, and how you can join the campaign. Those of you who are on here, a lot of you know, many of you have probably gone through this, but it gives you step-by-step process. And Umar, this is something you should take a look at some point. You and you know others as well, and teacher to go through this. And this shows you how to join the campaign and what you need to do to review the tree height measurement tutorial slides, basically to help guide you through how to take the measurements. And then we have the, we have the start taking measurements link. And this talks about the protocols, some of the guidelines for taking tree height measurements. So you can see the main protocol is biometry tree height. And then we have the complementary protocols, is green up, green down, land cover classification, and carbon cycle, which I'm not an expert in, but we added that to this. And then we have some suggested baseline protocols. You know, when you're taking observations of tree height, you know, it's great to take as many other measurements as you can. If you can do land cover and green up, green down, that's awesome. But we also like to know what's happening in your environment completely. You know, so take, you know, air temperature, take surface temperature, take soil temperature, you take soil moisture. You take as many measurements as you can in that same location. So it really paints a really strong picture of what's happening in in that environment where you're taking those measurements. All right, now we have the webinar page, and this shows you the upcoming webinars. This one right here is the one we're doing right now. This is the next webinar, November 12th. We'll talk about that in a second. And then we have all the archived webinars, all 13 webinars from, all 12 webinars, all 12 webinars from the first year of the campaign, and they're all here. You can click on them and watch them from this page, or if you click on it, there'll be a little thing on there that says YouTube. You can watch it on YouTube. So, but everything is here. And from each of the webinars, if we had something to be shared, there is a link to these as well. There's a link to some of the visuals. the presentations. They all have links to the things that were shared during the webinars. So this is a great resource for you to take a look at. And I mentioned earlier that Marcus gave a presentation at one of the webinars. This was his, What Green's Up, Must Green Down, Greening's Live from Switzerland. You can take a look at the research that he and his students, and Marcus is a Globe Master Trainer. You can take a look at what he and his students, the research that they have done. They have done some great research questions, and he works with something called Phenocam, you know, a way to look at, it's automated cameras that take images of the trees, and you can create time-lapse videos. So it's really cool presentation that Marcus did. And then also we have all these archived ones as well that you can look at from different presenters, from students to research experts. The guiding investigative questions that we just went over, we actually have a separate page for those, and we have these on here. It's not a big page because we're just adding to these as we go, because we're thinking of things that students really want to use to explore the data that they're taking and the data that others have taken. I mentioned that a lot about, you know, we really want to focus too on the data that others have taken, because there's lots of data out there. We have over 8,000 tree height measurements that can be used for any type of research project. That comes, I can't remember how many countries that was from, but it's from over at least, I think it's 50 or 60 countries where this all comes from, where these guiding investigative questions come, where the data comes from that can be used for students to look at for student research projects. And we have a page for the intensive observation periods. Sorry, I'm used to talking really fast, so I'm kind of stumbling over my words. I'm talking too fast, so I need to just slow down, chill out, slow down, right? So here we have, you know, the award winners that I mentioned earlier, all on the intensive observation periods page. And then we have a couple other ones here. We have a link that takes you directly to the globe visualization page. And then I won't go to all these. We have one that lets you go to, it goes to the, I'm just gonna click on it, the Advanced Data Access tool. And then you can go and look directly up carbon cycle data, green up, green down data. You can visualize tree height data and all this stuff on the maps. You can look at something called open altimetry to visualize the ICESat-2 data. Then we have a site here that talks all about the ICESat-2 mission and what it is and what it does. And we have a great campaign community page where there's 3 sections here. We have discussion forums where people come in and talk about different things that they've been doing. This is great to, you can start new threads. Anybody can start a new thread if you become a member of this. And I should mention also here on the campaign community page, all you have to do to become a member is you scroll down here and then you go to right above the map, it'll say join community. Mine says leave community because I'm part of it. But if you hit join community, you'll become part of it. You can see people from all over the world have come in here and join the community. So on this page, once again, we have these guiding investigative questions for data collection and research for the students to explore. But we also, and what Peter Nelson is going to talk about at a future webinar, and we're going to put a feature on this site soon. He's going to talk about some of the great online tools that students and teachers and researchers can use to take the data and make sense of it just a little bit better. And these are examples of some of these resources, these online tools that you can use to look at different types of data, whether it be elevation data like tree height, or land cover data, or others. So this is great things. If you have things you think that should be on here, let me know as well. This is a campaign that is, everybody is part of it. Even though, you know, our team is leading the campaign, you know, our NASA team and Oregon State University team is leading the campaign. We're all part of the campaign. We all want to, you know, we want to discuss what's best for the campaign and what teachers need and what students need in order to successfully be part of the campaign. And then we also have a blog section here where there's different blogs that I put up and some others have put up over the last year. And then we have a document page where it's just, it houses all the documents that have been put up there, from images to feature articles and things like that. So, you know, it's a great community, campaign community page. So that's a little bit about the campaign website. Just have any questions? I see there's stuff popping up in the chat, so I got to open that and let me take a look at all that. All right, I see a couple things here. Yeah, thank you, Dorian. Yeah, the trees need to be at least 15 feet or 3 meters tall. The reason why that is we kept it that way because the original globe tree height measurement as part of the biometry protocol had that in there, and that was from that was put in there from the scientific consensus of what constitutes a tree. Anything under that is considered a shrub, and then you get down all the way to the grasses or graminoids after that. But one caveat here, let me say this, and you heard it from me, and if anybody says it's wrong, tell them to blame me. But I know there are some groups that like to plant trees like a sapling in their area and track the growth over time. You can actually do that. You can actually, plant a sapling. Now, if it's a tree that's, a foot tall, then it might be a little tricky. But if you plant a sapling that's like, 5 feet, 6 feet, 10 feet tall, go ahead and take an observation, take a measurement. I know you want to, track that over time. And if you do that using, the GLOBE program or the NASA Globe Observer Citizen Science Trees tool, you'll have a record of it. So you can really keep that record in there for, for years and years and years. It'll always be in there. So you can track it as well. So, that's just what we're going by, the 15 feet or approximately 3 meters tall. So yeah, thank you, Dorian. Yeah, so Marilyn, check that out. I wouldn't not take tree height measurements if just because they're not 15. That's just what we put in there as kind of a baseline, but definitely take measurements for sure. Yeah. So
hey Brian, it's Christopher.
Yes. Yeah.
I feel it's appropriate to mention that GIs stationed at Sandi Stromfjord, the Air Force Base on the western coast of Greenland, planted Native American trees up the fjord from where the Air Force Base was back in the 1940s. When I was last there in the early part of this century, they were maybe 3 feet tall. So you're talking oak trees that have such a slow growth rate.
Yeah.
They'll never meet the protocol, but they are definitely trees.
Right. Okay. Excellent. Yeah, I've been talking about that with some of the science community at Globe, and it's basically like we'll keep it in there for now type of thing. So I agree with you. If it's less than 15 feet, it can still be considered a tree. So with the Globe protocol, it's originally was put in there as anything under 15 feet is considered a shrub, which honestly, I don't know where that came from originally. I just know that that's historically what's in there. So we had to keep it just as kind of a baseline. But when I talk to people such as yourselves, I say, the sky's the limit. Go out and measure. If it's under 15 feet tall, who cares? Go take measurements. If it's 8 feet, 7 feet, 6 feet, take measurements. If you have an elementary school kid who's under 4 foot tall, say like 3.5 feet tall, and the tree is 6 foot tall, they can take a measurement. It's a little trickier when, like me, I'm 6'6", and I want to try to take a tree height measurement of a tree that's 3.5 or 4 feet tall. It's a little trickier. I'm not really looking up; I'm looking down at the tree, so it gets a little tricky. But yeah, take measurements. If it's under 15 feet, as I mentioned, who cares? Take measurements. It's great data. And as Christopher mentioned, some trees grow very slowly, and it's never going to hit that criteria of 15 feet. So yeah, sky's the limit. All right, let me pop out of here again, and I'm going to go back to the presentation here. All right. Now, I always like to show this video. This is created by our ICESat-2 team, and let me show this here. This is really fun. It's a promo video we created for the campaign. It's the one that I showed that was on the site, and so I showed it to you. Here you go. So the purpose of this video was to bring in that personal relationship with trees and a personal interest in trees to help spark the scientific interest of trees. So, you know, we, as I mentioned, first thing in the campaign, we all have something personal with trees. You know, we have our favorite tree. We love looking at the leaves. We look leaves change. We look for certain trees in our neighborhood. We see them just about every day. So, you know, how do we take that and then take it, build it into taking scientific measurements of tree height? You know, that's what the promo was about. All right. So, a little bit about the ICESat-2 mission. I'm just going to do a quick refresher here and why we talk about this. You know, as part of the campaign. The ICESat-2 mission stands for the Ice, Cloud, and Land Elevation Satellite 2. It uses an onboard laser system to measure the height of objects on our planet. And Christopher is a cryospheric scientist, so he is an expert. He is expert in from ICESat-1 all the way through ICESat-2 and beyond. The satellite launched September 15th of 2018. That was the same time we started the campaign last year, same exact time. We wanted it to correlate. And then the satellite has over 1 trillion measurements in 1 year. So that's just amazing stuff to think about. There's lots of data from the ICESat-2 mission that students can use as well. And that'll be a big part of the campaign. And then, you know, during this year is how do we look at this data, and a combination of Christopher's expertise, as well as next month, Amy Fitzgerald from the National Snow and Ice Data Center. She's an expert in the open altimetry program where we can actually, you know, look at some of that data. And then she's going to showcase a couple other things as well. As it was mentioned, it uses a laser altimeter system, and it measures the height of things on our planet. And I'm showing this here because we're focusing on trees. Trees is one of the big parts of what the satellite can measure from space. Now, let me show you this. This shows you a little bit more about ICESat-2. This is probably my favorite video, and I like to show it all the time.
From satellite data, we have a very good handle of how our Earth looks like. We can see oceans, we can see the sea ice, we can see our forest. What is much, much harder to measure is how high things are on a global scale. Almost impossible.
ICESat-2 adds the third dimension, the elevation. Repeating measurements from ICESat-2 will allow us to measure changes in the ice sheets or in the ocean or in land.
ICESat-2 is designed to measure the changes that are going on in the cryosphere, in the polar regions.
All the change is at the edges. Those are the steeply sloping parts of the glacier that interact with the ocean, and that's where all the action is. That's where all the mass is being lost.
In order to estimate the mass changes, we need to know the height of things going on in the cryosphere, in the polar regions.
Sorry about that.
Change is at the edges.
Flip back.
Those are the steeply sloping parts of the glacier that interact with the ocean, and that's where all the action is. That's where all the mass is being lost.
In order to estimate the mass changes, we need to know the height of things. The mission ICESat-2 carries a single instrument. It's called ATLAS, the Advanced Topographic Laser Altimeter System.
ATLAS sends out small pulses of laser light 10,000 times a second. And by measuring precisely how long it takes that light to go from the spacecraft down to the Earth and back up to the spacecraft, allows us to figure out what the height of the surface is beneath ICESat-2.
We need to measure the time of flight of a single photon or a single laser pulse with a precision of a billionth of a second.
NASA engineers had to come up with entirely new ways of measuring time very precisely.
A billionth of a second translates to an elevation change precision of just a few centimeters. Climate change is amplified in the polar regions. ICESat-2 is designed to measure those areas and will help us to understand what's going on with our planet.
So as you know, ICESat-2, looking at ice, the ice sheets and sea ice and the polar regions is the primary objective of the satellite, to look at those changes in elevations of the ice. Because it's a global mission and it's called a near polar orbit, it's measuring anything that it can measure the elevation of, it does. I mean, for instance, if you look here, this happens to be in Mexico, and this is one of the first really cool graphs that came out here. And Christopher, you're familiar with this map, correct?
I have seen versions like this,
Okay.
not this particular one.
Okay, cool. So yeah, you've probably seen a lot more of the data, you know, than I have, but this is really cool because it shows you this blue line that you see is an orbit track from ICESat-2. And as you can see, that's a blue line. So if you take that blue line and you flip it 90 degrees, what you're looking at here on the bottom, all these blue dots that you see along this line here, all these blue dots, these are photons, laser photons. And if you look here, what's labeled the forested hillside, you can see where it corresponds to the map above it. You can see that all these these spikes and these peaks in the graph, these are all trees that are on this forested hillside. And then it runs all the way down into this lagoon. It's a Laguna del Mar Muerto. Oh, that's like the lagoon of the Sea of Death, isn't it? In Spanish, something like that. So if you look at this, you can see where that's all shallow water. So it was super clear, and you can see where the photons have penetrated the water, bounced off the bottom, and came back to the satellite. And then it goes out into the ocean, where you can see basically the ocean waves. You can see the waveforms from the coming back from the photon. So this is a really cool graph because it shows you just what ICESat-2 measures, and everything from a forested hillside down to the ocean. And once again, what the satellite's doing is it's firing off these laser pulses 10,000 times per second. These laser pulses are firing from the satellite, which is about 299 to 300 miles above the Earth's surface. And these photons are traveling to the Earth, and they're hitting the planet, and then they're bouncing back to the satellite. And those ones that bounce back in a straight line are the ones that are collected by the ICESat-2 mission. And we calculate the time it takes those photons to leave the satellite, hit the Earth's surface or whatever object it's hitting, like a tree or a building or a mountain or the ocean, you know, and then bounce back to the satellite. And if we look, we can measure just how high or what the elevation is of these things that the photons are bouncing off of. So it's really cool. So trees is a big part of it. That's why it's part of this campaign. And I'm not going to go through this really specifically. I'm just going to show you some screenshots here. But there's a website called openaltimetry.org, and it was developed at the National Snow and Ice Data Center to being able to look at the ICESat-2 data in this graphic form. So this is just two images here. One is ICESat-2 track and photon elevation data on open altimetry near Chicago, and then this is specifically in Chicago, and this on the right side is showing you, you know, where some of the tree height data came from around Chicago, right off of Lake Michigan. So these are some just showing you that they can be correlated. And next month, the November 2nd webinar, November 12th webinar, we will get into this more specifically. And here's just another track showing you it's running. This is the ICESat-2 track running through California, through East Los Angeles. And you can see on the right side, this is what the track looks like elevation-wise. So as you can see, all these peaks, just by this map, you can't tell exactly what they are, but they could be buildings, okay, could be trees. So we have to dive in a little further for that. All right. So the last thing I want to cover here in our time is just about out, but I'm gonna keep going for the next couple minutes. That's all I really need for this. But we have the NASA Global Observer Trees tool, and this is a great tool to take tree observations quickly and in any location, just using your mobile device. So here's a quick promo video, a couple seconds here. Well, I'll run through this. So we have ICESat-2 taking measurements from space. Scientists measure tree heights from space and compare it to elevation of the ground and the top of the forest. So using your mobile device, you can just take these measurements. So yeah, it's super easy to do. And what you have to do once you download this and you want to go take tree measurements, you have to do two things. You have to go through the introduction, which is very short. It talks to you about what the tool is and why it's there and why you're going to use it and what's good about it. And then we have a tutorial slide. So it's slides you go through, and I'm not going to go through all this, but I'm just going to show you what it looks like. You know, if you go through, hit the trees button, it'll take you through a tutorial, and then it'll tell you exactly what you're going to be doing in order to take these tree height observations. And it's super easy to do. You just have to go through the intro first. And during the introduction, what you have to set up, though, you have to set up how tall you are, because you're going to be measuring angles, and you're measuring angles from your eye level. So depending upon how tall you are, the app estimates, you know, what your eye level will be. So when you're taking measurements, you have to know your height, because when you're taking trying to get the height of a tree, you have to get precise angle measurements. And if you don't have your correct height in, you know, the angles are going to be different than what they should be, and therefore the tree height measurement is going to be incorrect. But I do want to show you this here. This is showing exactly how I took an observation, and this was this summer. So let me show you this here. This is just really cool screen grab. So I went to the trees tool and I did a new trees observation. Since I have an account on the Globe student side of things, these are all my organizations. So I chose ICESat-2, gives you day and time, and then it asks you for service conditions, just like a bunch of the other tools on the app. And then you measure the tree base. So what you do is you hold the phone with the camera at eye level, and you measure the base of the tree. And you try to line the best you can. You hit no or yes. I hit yes. So just keeping the phone at eye level, you measure the top of the tree, and see, I didn't like that. So I hit no, and then I went to do another measurement. Nice, yes, I like that. And then you ask to take a photograph of the tree. So you have that for the records. And then one of the most important things is you walk to the base of the tree in a straight line using your normal stride. And based upon the height that you put in earlier on the introduction part of the tool, it will estimate the stride for you. So when you count your steps, you get to the tree, and then once you walk to it, it'll ask you how many steps you took. I happen to take 31 steps. And then you want to set the position of where the tree is. If you don't like what it looks like on the map, you can hold two fingers on the map and move it directly to where that tree is on the map. And then you can enter a circumference. If you happen to have a tape measure with you, which is great to take out sometimes, you can measure the tree height at approximately 4 feet 5 inches from the base, from the bottom of the base. So I'm not going to continue. It took a little while for me to measure, because I was one person measuring and marking off the tree to get the tree circumference. But then you put it in there, then you hit finish, and then you can submit the data. You can review the data and then submit it to the Globe database. Actually, yeah, so I put 72 in, then I hit finish, and I didn't like something that I did here, so I can go and actually edit, because the circumference that I put in, I forgot it was 72.5. So you can go in there if you didn't like something, if you put something in wrong, and then what you do, you can change that, then you can go in here and you can send your observations to Globe. So that data will then be in there for others to observe look at, use. Students can use it for research projects. All right. I just want to mention one thing, and this is something that is recent, that if you're a teacher and you want to use the NASA Global Observer Trees tool on your phone or on your like iPad or one of your devices, your mobile devices, there's an option now that you can go in and change the current user height settings. So if you go in there as a teacher, when you started off and you put in there, say you put your 5 foot. Oh, I should also mention on the app you can choose metric or standard or English standard units. So most of you who are on here from different countries in Europe, you use the metric system. So you can put in there how tall you are using the metric system. So if you do that and you put how tall you are and you're taking observations and you want a bunch of students to go in and take observations as well, you can go in to the help menu on the app and then go and click on the change current user height and put the height in of the student who is about to take the measurement. And then when the next student comes in, you can do the same thing. So you can change that all the time. You just have to remember that when you want to do it again yourself, you have to go change it back. But we put that in there because we knew students, teachers will be wanting to do this with a lot of students, or even family members wanted other family members to try it. So that they can go in directly and easily change what the current user height setting is. So they can change their user height. Just wanted to mention that because that was just released in the latest update that came to the app. So, and also mention you should update your app. If you close it out and go into it, it says update available, definitely update it because there's always new stuff popping in. Little glitches happen here and there. So, those are, hopefully fixed. Little things pop up. So, yeah. All right. So the next webinar, and sorry, I'm going over here a little bit, but the next webinar will be Tuesday, November 12th at 2 p.m. Eastern Daylight Time and 7 p.m. Actually, it should be Eastern Standard Time, shouldn't it? Because we changed the clocks in, or 7 p.m. UTC. And this is called Getting Comfortable with ICESat-2 Height Data and the Open Altimetry Online Tool. And that was with Amy Fitzgerald at the National Snow and Ice Data Center. So please come back to that. Hopefully we have a lot of people for that because she's really good at explaining, the whole open altimetry tool and looking at the ICESat-2 data. And she has some really cool things. We talked on the phone yesterday during a meeting, and she's really excited and has some really cool stuff to show you and how you can look at the data from different aspects. All right. So, all right. And finally, campaign website. There's the URL. And then I also want to mention, if you would like for your students to present at a future Trees Around the Globe Student Research Campaign webinar, definitely contact me, brian.a.campbell@nasa.gov. And Umar, there's my email address. If you're still on, you can take a look at that and shoot me an email, and we can talk about how to be an awesome participant in this campaign and Globe in general. So, does anybody have any last minute questions? Once again, I apologize for going way over, but I just wanted this to be a really good informative webinar about what happened during year one and what we really want to happen during year two.
One quick
Hello,
note.
you said?
Go ahead.
Hello, Brian, you said that you will give your email at the end of the webinar.
Yep, it was at the bottom. Let me go back and share again. You can see it.
Yeah, I left because my battery was dead.
Okay, so I can say it to you. It's Brian. Oh, there. Can you see the screen if I share?
Wait a second.
All right.
I cannot.
Okay, so no, let me share now and see if you can see this. Can you see it?
Yes, now I'll save.
Okay, it's all the way at the bottom.
Yes, I've seen. Thank you very much.
Yep, you're welcome.
Brian, one quick note. Tom Newman, now the project scientist for the ICESat-2 mission, as Torsten's gone to headquarters, basically said that version 2 of the ICESat-2 data is a little slow to roll out, but it is coming. So
excellent.
Hopefully Amy will have access to that by the time we get together again in November.
Great, great. And can you explain just quickly to what version 2 means to the rest of the crowd?
There are changes to the algorithm, and so there are things which are being tweaked that allow the raw data from the ICESat-2 mission to be turned into the kinds of products that people like you and me are interested in. ATL06, ATL08 are focused on different parts of the world, or different have different processing needs. So those processing steps are getting revised to hopefully make those data more efficiently available in the future.
Excellent, thank you. So yeah, there's going to be some great data coming from ICESat-2, and just more for students and teachers to use. So we're trying. This year the campaign, we want to try to make it as user friendly as possible. That's why we're having people coming in from all directions to really assist the students. All right, anybody else? We are 13 minutes over right now, but thank you all for joining. And any questions, you have my email. You know how to get a hold of me. And also, our next webinar will be Tuesday, November 12th at 2 p.m. Eastern Time, 7 p.m. UTC. And I will stop recording right now.
Goodbye. Thank